Hello everyone, let's talk about another medium problem on Leetcode today, maximum total number of roads, Leetcode 2285. In this problem, we are given an integer n denoting the number of cities in a country. The cities are numbered from 0 to n minus 1. Then we are also given in 2D array roads, where road I denotes the connection between two cities AI and BI. Then we need to assign the number between 1 to n to each of the city, where each value can only be used once, such that we get the maximum total importance of all the roads possible after assigning those values. The importance of a road is then defined as sum of values of the two cities it connects. Then they have given some examples as well. In example 1, we can see that this is how the graph looks. So there are 5 nodes from 0 to 4, and the roads are connected between 0 and 1, then 1 and 2, then 2 and 3, then 0 and 2, 1 and 3, and finally 2 and 4 as well. Then the output comes out as 43. Let's understand why. So the way they have assigned the values is that 2 is assigned a number 5, then 1 is assigned a number 4, similarly 3 is assigned a number 3, and similarly rest of the nodes. Now to calculate the importance of the road, we will just add these numbers assigned to the nodes or the cities. For example, the importance of the road between 2 and 3 is 5 plus 3, which is 8, right? Similarly, the importance of the road between 1 and 2 is 5 plus 4, that is 9. And then to get the total importance, we actually just sum up all the importance of the roads. Now that we have seen the example, let's jump into the solution space. Now let's think about it. Which city will actually contribute to the maximum importance of the road? The city which has the most number of connections or with most number of neighbors. So for example, in this example, we can see that 2 is that city, right? Because 2 has the highest degree, that is 1, 2, 3, 4, which is the maximum degree or which is the maximum number of edges connected to the different neighbors. And that's why we will be adding it 4 times when it comes to calculating the importance of the roads connected to it. So we should assign the maximum value of n, that is 5, to node 2. So now 5 is gone. So now we find the next city which has a maximum number of degrees. So in this case, it will be 1, right? Because it has 3 degrees, 1, 2, and 3. So that's why now we will assign the value 4 to it. And we can see that 4 will occur 3 times when we are calculating the importance of these 3 roads, right? So that's how the whole logic will work. Then we can see that node 0 has degree 2, right? And similarly, node 3 has degree 2. So we can assign either of them 3 or 2. So in this example, they have assigned 3 to node 3. So now the next node in line is 0. So we will assign value 2 to it. Note that even though 3 and 0 had the same degree, that is 2, and we already assigned the value 3 to node 3. So we cannot assign the same value to node 0. So that's why we assigned the value 2 here. And finally, node 4 has the least degree, that is 4. So we will just assign the value 1 to it, that is the last number possible. So that's how the whole values are assigned. So now let's try to dry run this logic. So the idea is simple, that we actually calculate the degree of all the nodes, then we sort them in ascending or descending order, and then we start assigning the numbers to those nodes and eventually calculate the maximum total importance of the roads. So now let's see this in action. We can see that for node 2, the degree is 4. Similarly, for node 1, the degree is 3. Node 0, degree is 2. Similarly, for node 3, degree is again 2. And for node 4, degree is just 1. So now we start assigning the values to it. So suppose we assign 5 to this one. Then we assign 4 to this one, 3 to this one, 2 to this one, and 1 to this one. So what will be the contribution of node 2 to the overall importance of the roads? It will be 4 into 5, right? And the reason is we are adding 5 4 times because it will be added for the road between 2 and 4, between 2 and 1, 2 and 0, and 2 and 3. So that means it has degree 4 and we have to keep on adding 5 that many times. Similarly, for node 1, we can see that the degree is 3 and the value is 4. So overall importance is 12 here. For this one, it is 20. Then for this one, it is 12. Then for 0 to 2, we can see that the importance is 3, degree is 3, and overall importance is say 6. Similarly, for node 3, the degree is 2 and importance given to it is 2 as well, so it will be 4. And for last node, it will be 1. So if we add it up, it will be 32 plus 6, 38, plus 4, 42, and plus 1 is 43. So that is how we will actually calculate the maximum total importance. Now let's jump into the coding part. Now, first thing we need to do is we create the degrees array, which will contain the degree of n nodes. So now we will start calculating those degrees by looping on the rows array. Because it is an undirected graph, we will increment the degree of both the nodes connected to that edge or road. Now we will just sort those degrees. In the example, luckily, it was already sorted for us in the decreasing order, but we can also keep it sorted in the increasing order. Now our answer is long, so just initiate it. Similarly, the first number we need to assign is 1. So now what we will do is, because the array is sorted, the degrees array is sorted in ascending order, we will just start assigning the numbers from 1 to n. Let's run the loop on the degree array. So answer will be equal to degree into number, and we will also increment that number afterwards for the next iteration. Also, because we are multiplying two integers, the output may overflow, so better cast it to long at the time of assigning, and that's it. We will just return the answer. So now let's run this code. Awesome. Let's submit this code. Cool. In terms of time complexity, it will be O of n log n plus e, where n is the number of nodes and e is the number of edges. Because we are looping over this rows array, so that's why we need O of e. And then we sort the degrees array, which is of length n, so it will be n log n. So that's why the overall time complexity is n log n plus e. In terms of space complexity, because we are using this degrees array, so it will be O of n. I hope this was clear to you. If this video helps you, please like and subscribe. Have a nice time. Thank you.